They're specifically interested in people who have leadership positions on campus. And not just, this does include leadership positions in university clubs, but they were specifically trying to be able to meet with like the student body president, some of the, y'all have senators here, right? Senators. And so that's what is it about those students that you like? What is it about this leadership that's so important to you? And they went through a number of things. You know, the people who try to be leaders of organizations are generally students who do well in school, good grades, things like that. But the main reason, they said, was they want people who are self-motivators, meaning if they're grooming someone for a good management position, it cannot be the kind of person that has to be told what to do. For a person in a management position, if they wait around to be told what to do, they're actually a net drain for the company because it's more work for them to tell another manager what to do. They want someone who's going to come in and wants to figure out their own way of contributing to the organization, finding their own solutions to problems, and also finding their own problems in the company that they want to come. So it basically all boils down to, for them, motivation. Whether someone's a self-motivator or not. Not all organizations are like that. I've met some people who don't care whether you're in a leadership position in the club or not. But it was an interesting conversation, and I thought you might find it useful. So today what we're going to be doing, there's a worksheet up here. We're going to take notes on the worksheets. I didn't want to just hand it to you because I think for today's class, actually writing down the problem helps you understand it. We have homework A that's on real, and I'm going to price this up on the web. Coming Wednesday and coming Friday, there's going to be no new homework too. You may want to go ahead and get this done. Exam on grades, everything we've done this far. If you want to come look at it, you can meet with the TAs during the office hours or arrange an appointment. They'll break out all the Scantrons, all the hard copies, and the answer key. You can look at your Scantron, your test booklet, compare with the answer key, and ask all the questions that you want. I don't want you to take it home with you because if you do that, then you no longer have an opportunity to bring it back and say, I think there was a problem in the grade. As long as we keep it, we can always rectify any problems you may see. But otherwise, you take it, change what you get with your answer, and so on. And if you want to see where you stand in the class, there's this link to a spreadsheet. You can go in and you can say, well, what if I do make a 95 on the next two assignments and then 90 on the class paper? Where will I stand in the class in that spreadsheet? It can be useful for that. I'll show you a quick video before we get started. We're going to do the video, 2 clicker questions, then notes on the board. Anything I need to tend to? Questions? Labs, I'm just showing up. I won't take attendance, but I think now's a good time. I'm starting to get some emails or questions. That's a good time to come to lab and chat with me about the paper. And I guess we'll go here. Our collective loss. So basically what that video was doing is Homer's trying to make some money selling bacon grease, and he ignored a very important cost, the production, meaning he was taking bacon that his wife made to make bacon, and then he took the grease and sold the bacon grease, and the money he got for the bacon grease he was thinking was pure profit, but he wasn't taking into account that his wife Marge bought the bacon, his wife Marge got the money from him, and so on. So what he was doing was ignoring a very important part of cost of production. When we're talking about profits, we're thinking revenues. minus the cost. We want to make sure we have a very enlightened view of what cost is. And that's what we're doing today. We're looking at opportunity costs and saying, let's make sure we thought about all the costs involved in the production of the good. I want to review one of the opportunity cost questions that we did last time. Make sure you're on channel 46 again. I'll let you read it. Remember, opportunity cost, value of the next best alternative. So the opportunity cost of raising cotton is the value of the next best alternative to raising cotton. Let's start the timer now. Good, yeah. Almost everybody's got it now. This is an accounting cost. Cost of production and accounting cost of cotton. Just the cost is meaningless unless you know the revenues that have to go with it. And it's not just revenues or costs that matter. All that matters is profit. And so what we're saying up here, they can make $300 in profit. So you don't need to know anything more about cost. That information about cost is irrelevant to the question. A person can make $300 raising cotton. What does he give up by doing that? He gives up the opportunity to raise the next best thing, which happens to be corn, and he can make $250 raising corn. What he's doing is more valuable than his next best alternative. That's an indication that he is maximizing profits. Value of the next best alternative. Now, next one's going to be a very similar question, except the profits from raising soybean changes, and I want to ask you, how does that change the opportunity cost of cotton? It's not asking what is the opportunity cost. It's asking how does the opportunity cost change. The soybean profits rises to $2.40 per acre. Right. Does not change. Even if the profits from raising soybeans going up, the value of the next best alternative is still corn, and the profits from corn is still $2.50. So unless that next best alternative makes more or less money, then opportunity cost doesn't change. Now, with this is said, what if the profits from soybean production rises to $2.60? Then things change. Because now, the next best alternative is not corn, but soybeans. And the profits of the next best alternative go from $2.50 to $2.60. So in that case, the opportunity cost would rise by $10. What I'm going to do now is a forestry example where we're talking about a stand of trees and we want to know when is the best time to harvest trees. And this is a very simplified example. A forest is a very complex thing to manage. You know, it's not just one product that you make and that's it. A forest is an ecosystem. And how you manage trees today impacts the amount of trees you can harvest, not just from the current stand, but the next generation of trees, and the next generation of trees after that. Forestry is not a simple problem, but there's no way you're going to be able to understand how to actually manage a stand of trees unless you can first do the simple problems. So we're going to take a very simple example where we have a stand of trees. It's growing. We know exactly how much they're going to grow in the future. We know exactly how much the trees will make in accounting profits if we harvest it this year or next year. And we're going to try to determine when should we harvest trees. But when we're doing this, we're not just asking at what age do we maximize the profits from our trees. We always want to consider the alternative. And we're going to say, if we have a stand of trees and we let it grow next year, and it does grow some more, and it can make us want more money, we can't stop there. We should also ask, well, instead of letting the trees grow another year and get more money from that, what if I harvested the trees now, took the money, and maybe invested it somewhere else? When you manage and stand the trees, you're not just managing the trees, you're also thinking of your other options. You want to know, should I let these trees grow another year? Should I harvest now and invest the money at a certain interest rate, like 3%? And we're going to start off with our stand of trees, and we're going to be making tables today. The first one is going to be just a 3-row, 5-column table. And we're just going to be looking at 2 years. We're going to say we have some trees now, and we just want to know, should we let it grow another year, or should we harvest it now? And this question is going to be on exam 2, there's going to be a question almost identical to this. So this is one of those things, the question can be a little hard to understand, but once you've got it, you know you can answer a question on the exam that's going to be working a fair number of points. So here's what we're going to have as far as I take it. We're going to have a year, 2012 and 2013. 2012 is now, we're pretending. We have an age of our stand of trees. And right now the trees are 20 years old. We let it grow another year. We harvested 2013. The trees will be 21 years old. We're going to have a column that tells us the tons per acre if we harvest in 2002-2012. A column for accounting profits. If we harvest in year. So our number here will be the profits we made from harvesting trees if we harvested in 2012. The number we have here will be the profits we make if we harvest the trees in 2013. And we'll think about opportunity cost, next best alternative. What is the next best alternative to letting the trees grow another year? And this is going to be our last column. Accounting profits. If we harvest trees last year, and invest profits at 8% interest. That column tells us the profits if we harvest the trees in that year. This tells us, well, what if instead of letting the trees grow another year, what if it's 2013? What if instead of letting the trees grow in 2013, what if we harvested it last year, took that money, and invested it, and we're assuming, and this interest rate, I've always got to give it to you. Your next best alternative to letting the trees grow is to putting it into some kind of instrument that earns interest, like a bond or a CD or whatever it is. But I'm telling you the interest rate. Now I'm going to go ahead and we're going to put the tons per acre you can get from harvesting the tree. In 2012, you can get 15,000 tons, and these are tons per acre. If you let it grow another year, you get 16,000 tons. So let the trees grow another year. You're going to get more trees. And of course, you'll get more profits. Now, to know how much money you make from here, you have to know the price per ton that you're going to get for the trees. So above here, I want you to write, you can get 50 cents per ton. For every ton of tree that you harvest, you can get profits of 50 cents. So those are 50 cents per ton profits. And so if we have that, we know how much money we can make if we harvest in 2002 and 2012. And we'll put that down. For 2012, we can harvest 15,000 tons. We get 50 cents per ton. 2013, if we let it grow another year, we'll get 16,000 tons. We still get 50 cents per ton. I encourage you to crunch the numbers later. Even though I did it, I'm going to stop, take up my calculator, crunch number 2 to make sure I don't go too fast. $8,000. Price per ton, tons per acre. So this is profits per acre. And I'm going to stop the little calculator even if you can just look at it and do the calculations. Those 2012, if we harvest now, we'll get $7,500 per ton. If we wait another year, we'll get more profit. We'll get $8,000 per ton. But we don't want to stop there. We want to say, well, what if I don't let the trees grow another year? What if I harvest now and go to my next best alternative? It may end up being the best alternative. I take that money, I invested it at 8%, and let it earn interest between 2002 and 2013. What would be my profits then? For this column, we can't say anything about 2012 because we don't know what happened in 2013. But what we do here is we're saying, okay, it's 2013. If I had harvested trees last year, I harvested last year and got that $7,500. And put it on a financial instrument and let it earn 8%. So I get back 1.08. I get $7,500 back plus 8%. How much money would I have then? I get 8,100. So still saying per acre because everything here is per acre of trees that we had in the first place. So we should not have let these trees grow from 2012 to 2013. It would have been a mistake if we did. So long as this problem is as simple as this, and so long as all we care about is the amount of money we have in 2013, we'd be better off to harvest the trees before their maximum growth and invest the money at an interest rate. What this tells us is that when it comes time to determine when we should harvest trees, it's not just a matter of forestry, it's a matter of economics. Because the interest rate is going to help us determine when we should harvest trees or not. The age you harvest trees depends on forestry principles, but also economic principles. to do now is we're going to take this example and we're just going to add more rows. We're going to have a bigger table. Instead of just 2 years, we're going to have 5 years. We're going to be doing the exact same calculations, but now we're going to be projecting into the future to say what age would be the best time to harvest fruit. I'm going to sketch out the whole table before I start filling stuff in so you can see how to transpose it on your paper. Instead of having years, I'm just going to have age of stand, of the tree stand. Columns are going to be exactly the same. You can how many tons per acre you would get if you harvested it at a different age. You've got the counting profits, harvesting it in each respective year. The last sheet, counting profits. This tells us the profits. We harvest for 28 years or harvest for 30 years. Whereas this column is going to be the counting profits that we harvested last year. Let's assume we invested money at an interest rate we harvested last year. And the interest rate is 3%. Again, I've always got to give you those percentages. I'm just going to have a couple of notes right here that you can put under your table. Mine will be 2 choices. At any age, when we think about what happens to trees in the next year, what we're looking back, every year we have to make a choice. Let trees grow another year. Or harvest now and invest profits. Managing trees, and wherever you are right now, we say I can let the trees grow another year, I can harvest now, invest the money. With these 2 options, which will give me more money in 1 year's time? Another thing I have to give you is the tons per acre, and they're going to be as follows: 12,000 tons per acre, 14,800 tons per acre, 16,000 tons acre, 16,800 tons per acre, and 17,000. 12,000, 14,800, 16,000, 16,800, and 17,000. At this point, you have everything you need. And then what we're going to do, we'll go ahead and fill in everything here. And I'm going to start from 28, and I'm going to talk our way through it as we go. We're going to say we start at 28. We look ahead, should we let it grow another year? If we do, we move another year. We say now, 29 years, do we let it grow another year? And so on. So we pretend like we're going through time just as the trees grow, if we allow that to grow. The county profits, if we harvest now, we take our 12,000 tons per acre, multiply it by $0.15 per ton, and we get $1,800. Now let me go ahead and do 29 years too. Suppose we let the trees grow another year. Then, if we harvested when they're 29 years old, we get 14,800 tons. The price is still the same. Doesn't have to be, but in our examples it will be. 2,220. So definitely, starting from the year when the trees are 20 years old, if we let them grow another year, the trees will grow, and our county profits from harvesting would rise. But then we want to say, what's the alternative? Instead of letting these trees grow another year, what if we harvested here, took the money, and invested it at 3%? I mean, we don't have anything to put in that first row there because we don't know how big the stand of trees was last year. What we do is we say, what if we harvested? Meaning when we're asking how much money will we have when the trees are 29 years old? Well, we harvested when they were 28 years old, when we could have gotten $1,800. You may want to put a dollar symbol in front of it just to make sure you understand. This doesn't refer to tons of trees. We harvested last year, we would get $1,800. We invested it at 3%, so we multiply that by 1.03. It's the same as 1 plus 0.03. And we would have 1,854. If the stand is 28 years old, should we let it grow another year? Yes. If we do, our profits will go to 2,220 after 1 year, whereas if we harvested now and invested money, we would only have 1,854. So we know we're going to let the trees grow at least one more year. We know that the tree will be at least 29 years old. And then we just keep doing that for every year and asking the same question. The trees are now 29 years old. Should we let it grow another year? Well, if we let it grow another year and harvested it then, we would have, the trees would grow more. They would grow from 14,800 to 16,000 tons per acre. Price is still the same. Doesn't have to be, so in this example, we'll kill. So if we let it grow to 30 years old, it would then be worth $2,400 per acre. Now we want to say, what if instead of letting it grow another year, we harvested it when it was 29 years old and invested the money? Should we let the trees grow another year? Yes, absolutely. If we do, next year when the trees are 30 years old, it'll be worth $2,400 per acre, whereas if we harvested last year and invested money, we would only have $2,286 for every acre of tree that was planted. So we would have more money by waiting another year and the growing money. So the trees are going to grow at least to 30 years of age. And suppose that happens. Now the trees are 30 years old. And again, we do the same thing. Should we let the trees grow another year? If we didn't do that, if we didn't let it grow to be 31 years of age, we would have harvested it when it was 30 years old, taken the profits of $2,400, let it earn 3%. $2,472. Should we let the trees grow another year? Yes. So we do that. Now the trees are 31 years old, and we ask the same question again. Should we let it grow until it's 32 years old? So then we'll be able to harvest 17,000 tons per acre. We'll be able to get 15 cents per ton, 2,550. $2,550. If we didn't do that, we would have harvested when it was 31 years old, got the profits of $2,520, invested it at 3%, and we would have had $2,000. Do we let the trees grow another year? No. Now we're at the point where we say, we could let the trees grow another year, and it would make us more money. Our profits would go from $2,520 to $2,550 per acre, but we could have instead harvested when we were 31 years old, invested the money, and waited another year, let it earn 3% interest. Then we would have $2,595.60. So what this tells us, we harvest when trees are 31 years old. So how much wood people harvest every year depends on what the interest rates are. How much they can make in a CD or corporate bond, or even the stock market. That interest rate is what the company thinks it could earn in its next best alternative. So once again, economic principles help determine when trees need to be harvested. You cannot manage a stand of trees without knowing some economics. Here's our last question I want to ask about it. Any questions about this? Yeah.
What if, what do you also want to take into account the interest rate, though? And, the inflation rate?
It would be embedded in the interest rate. It depends on how you do it.
I mean, if you cut the trees down now, you're going to get less money than if you cut them down. I mean, same amount of trees, you'd still get less money than if you did 10 years from now, assuming.
Well, if there's inflation, generally you think the price of trees would go up with the inflation rate. It may not. It doesn't always do that. So there are some other things you can do in here to account for whether the real price of trees goes up and down with inflation. And whether it does or not depends on that interest rate, whether you should use a nominal or real interest rate. They're a little more. And you know, you may be wondering, well, what if the tree could grow a bit older? How do I know when I stop at 31 years of age that it would actually be better if I waited until it's 35? Well, we don't know what happened down here. I'm just assuming if we know to stop harvesting at 31 years of age, then it doesn't matter what happens down here. Well, what happens is that the trees, just like crops, just like you, when you were little, you grew really fast. When you're teenagers, you were still growing, but your growth rate fell. You're about at the point, well, you're not there yet. You get a little older, you'll hit your maximum growth rate, and then you'll actually start to shrink a little. Same way with trees. Every time you let trees grow another year, when they're young, they grow a lot. When they're old, they grow a little. And so let them grow another year has a diminishing return when it comes to these accounting profits. But when it comes to interest rates, when it's multiplied by a bigger number, it gets bigger, bigger, bigger. So it turns out, if you just use this analysis where you go year by year and you cut it off when the trees are 31 years of age, that is the final solution, even if you knew what happens throughout the next 100 years to that tree. So long as trees are like you and their growth rate falls as they get older. Which is true for most trees, except redwoods. Redwoods, their growth rate actually increases the larger they get. So you would have to do something more than this to figure out redwoods. Final question. As the interest rate rises, trees are harvested at a younger or older age. Raise your hand if you think older. Raise your hand if you think younger. All right, because what you're seeing is you replace that 3 with a 10, this number over here gets bigger, which means at an earlier age, it will become larger than that number up there. It turns out that if the interest rate was 10%, you would harvest the trees some of you didn't have that. If the interest rate was 10%, you would harvest the trees when they were 29 years old. Very useful, practical example. That's all. See you later.